Hopefully you have already downloaded or opened up the notes that are online. If not, please do so because I am not going to write out everything that's already up there. So, exponential functions is what we learned last week. Now we're going to add, well, that's not what I wanted, log functions. Okay, they are inverse functions. Again, this is nice and neat on the notes that I printed. So, if you remember, inverse functions is the same function, right, but inverse operation. So this b means the base, this x is the exponent. So this is something you've seen time and time again, where b raised to a power equals a number. So now with log functions, the same b, right? However, the power is the result, and then the y, original result, is what you're logging to. So same b, same x, same y for an exponential function. Example, 25 is equal to 5 squared. Hopefully that's something that we know. We don't have to think about. So if I was to write it in log function, log would be base 5 of 25 equals 5. And you read this, log base 5 of 25 is 5. Okay, this is how it's read. Okay, next page on the notes is we're going to be taking exponential functions and we're going to write them in log form. If you would like to look this up on the internet, right, to get some secondary notes, that's what you would look up. So if I had 49 equals 7 squared, again, common fact we already know. The 49 is my y, the 7 is my b, the 2 is my x. So when I go to write that in log form, log base b of y is equal to x, I'm going to write log base 7 of 49 is equal to 2. And you're just rewriting that in log form. We went over exponential form and the uses of it. Your goal today on Google Classroom is to find the uses of the log function. I'm not going to necessarily tell you that. I did tell the few that were on live yesterday, but okay. Another example that is on your notes is raised to the 2 equals 0.1. So again, I would just make that log. However, whenever we have a base of 10, we always count in tens, right? 10, 20, 30s, 100s. That's the metric system. So you don't have to write the 10. Any natural log, any log is already a base 10. So it would just be log of 0.01 is equal to -2. Okay? Hopefully we understand that. So whenever it's base 10, here's another example. 10 to the power of 3 is 1,000. So log of 1,000 equals 3. No need for the base 10. It's already a given thing. Okay? So there are 3 more examples on the notes that you can go ahead and try. I'll probably put like what's the answer to those tomorrow so that, you can get the answers. So now we're going to go the other way. Log to exponential. And again, if you want to look it up on the internet, how to write logs to exponential, that'll give you an extra time. So now this page printed differently, right? Because it did not print the subscript of the log. So all those logs with a number touching the log are the base, right? So on your notes, it says log 2 128 equals 7. What that should be is log base 2 of 128 equals 7. So it just printed funny. So when you go to do the practice problem, D, E, and F, make sure that you write it out correctly so you can actually get the right answer. So if I was to write that in exponential form, right, I would have, remember, this is B, this is Y, this is X. So in exponential form, 128 is equal to 2 to the 7th power. And if you just use your calculator and you did 2 to the 7th power, you're going to get 128. Okay? Another example. Log base 6 of 6 equals 1. So remember that logs means exponential form, right? So this would tell me that 6 is equal to 6 raised to the power of 1. And hopefully we remember our powers and rules of exponents. Any number raised to the power of 1 is going to be itself. So whenever you have a log raised to itself, raised to its base, you're always going to get 1. You shouldn't have to do any math. You shouldn't have to do any thinking. You should be able to get that result. The last one I'm going to do is log base 2 of 1/2. Okay? Don't be confused about fractions. Remember, they're just numbers. So if I write that in exponential form, 1/2 equals 2 to the negative 1. So remember, any power raised to 1 is itself. However, it's a negative, so it flips on the bottom. And that's why you get this fraction. Okay? There's 3 more for you to do on your own. Okay, and you use this rule in order to evaluate. So again, if you want to look this up on the internet, you can look up how to evaluate logs. So you just use changing it from log function to exponential in order to evaluate. So the first example I give you is log base 2 of 16 is equal to x. Okay? So I change that to the result, which is 16 is equal to the base raised to the power of x. So I have to figure out 2 to the what power gives me 16. So 2 times 2, 2 times 2 is 4, times 2 is 8, times 2 is 16. So to the power of 4. So if 16 equals 2 to the power of 4, then x is 4. Okay? I'm going to do one more. Log base 4 of 64 is equal to x. Right? So then I have 64 is equal to 4 to the power of x. And now I have to find 4 times 4 is 16 times 4 is 64. So 64, oh my goodness. So 64 equals 4 cubed, which means x is equal to 3. Okay? There's one more up there you could practice, and you can also search some other examples if you can't get onto big ideas. Big ideas definitely gives you some practice. I'm going to put some worksheets up as well. All right, so the last thing is properties. Properties of logs. If you want to look it up, that's what you would look up, right? So the first one is the product property, which is just saying the log has to be the same base of m times n. And it just means that you can separate that to adding the things that are able to be multiplied. We're going to do an example. That's confusing. But if these things are multiplied, then you can add them together. Quotient. If I said log of m over n, then you can subtract them. Okay? And they can go back and forth. If you had two logs that were being subtracted, you can divide out their result. And the last thing is the power function. And this is just expanding the power function. And power is just a property of multiplication. So you could take that power and multiply it to that log function. Okay? We'll bring it in front. So those are the properties. We're going to do some examples. So log 3 of 4 plus log base 3 of 6 equals log base 3 of 24. Because 4 times 6 is 24. Okay? So then if I had log 12 plus log of 2, and remember, when it's base 10, you don't need to say the base, you don't need to write the base. So this is log of 12 and log of 2 is going to be equal to log of 24. Because if they're separated, remember 12 times 2 is 24. So now you can go the other way as well. If I had log base 5 of 10, I can break that apart to two things that you can add together to get 10. So I can do log 7 base 5 plus log base 5. Oh, it's multiplication. I am such a bad person right now. Sorry. Base 5 of 5, log base 5 of 2. So 5 times 2 is 10. You can go the opposite way. So this is the last one I wanted to do. Actually, no. I'll leave that last one for you to do. Again, we'll do the answer to that. However, I'm going to do this same one. Log base 10 can also be log of 1 plus log base 5 of 10. Right? Because 10 times 1 is also 10. Okay? And then you can do the last one on your own. Let me tell you, teaching without students, this is the worst. I really miss you guys. I would never want to do this with my life. Alright, quotient. Log base 2 of 32 minus log base 2 of 8 equals log base 2 of 4. So 32 and 8 are my prime here. Right? And subtraction means you use the division property. So 32 divided by 8 is 4. Log base 5 of 36 minus log base 5 of 4. And again, if I had 36 divided by 4, I'm going to get 9. So this would be log base 5 of 9. Okay? Again, it works the same going backwards. If you already have the division quotient, right, this you can separate it. So this would be log base 7 of x minus log base 7 of 12, right? And it's a little bit easier to do when you're already given this nice fraction, right? However, when you're not given a fraction and it's just an integer, right? Now you can decide what factors you want to use. What factors of 10 do you want to break apart? So again, it has to be two numbers that are going to divide to get you 10. That would be, let's say, 100 and 10, right? Because 100 divided by 10 gets you 10. No, it doesn't, when it comes to expanding, this is what this is called expanding. When you go from the one simple form to the breaking into two different logs, it's called expanding. You can look that up on YouTube as well. Expanding logs. Okay. The last one we're going to go through is power function. So the power property of logs And this one, you're just manipulating the numbers. So you just take the exponent and you multiply it, which means you bring it to the front. Okay? That should be the easier one for you. Okay? Don't let it confuse you. The next one, log base 5, 7 over 3. Okay? Take a minute, think about it. What happens? The exponent just comes to the front. 3 log base 5 of 7. Right? Nothing's really happening. You can also go the other way. 4 log base 3 of 10. Right? And now you can bring that 4 to its exponential form. So base 3 of 10 to the 4th. There's one where it's not written in an exponential form, but you might be asked to put it in exponential form. This is usually good for when you're solving, right? You'll do that in pre-calc because we're not going to get there online. But if I was to change that, oh, that's not supposed to be a 10. I was like, ooh, sorry. So if I was to change that to log base 5 of 4 squared, right? Now I can write that as a power function, 2 log base 5 of 4. And I know at this point, you're like, why would I do that? But again, that comes with solving, and we're not going to get there. I'm sorry, I hate not giving you a why, right? That's the power function. The other notes, change of base is up there, and all the steps are given to you, right? This is very important in pre-calc. However, you're going to miss it. This is just for notes. It's not on the quiz. I just wanted you to see it, have it. Those of you who want to reflect on it, you can save it to a file for next year or 2 years if you're that kind of student. If you want help on this, you can definitely ask me questions. I'll give you some problems. We can do some together. If you have access to big ideas, right, you can just open the book. I think it's chapter 6 in Big Ideas. And then you can do some practice problems there. Again, I'm going to upload the Common Core practice packet so that you can do some problems. Hopefully this is helpful. I'm very sorry that you guys are going to school like this. Miss you.